video, we are going to talk about Thales' theorem. Now, who is Thales? Thales was a Greek philosopher, يعني عالم يوناني. So he was a Greek philosopher in math, physics, and astronomy. And he came up with this theorem when he was calculating the height of a pyramid in Egypt. And he was very popular since then. And that is a story that we are going to demonstrate in another video. But for now, let's see what is Thales' theorem. Okay, let's get started with activity 1, in which we have 3 lines parallel to each other and at an equal distance separating them. So the distance between D1 and D2, as you can see, 2 boxes, and the distance between D2 and D3, also 2 boxes. Okay, so we have a secant cutting these 3 lines in A, B, and C. Okay, and the question is show that AB equals to BC. Okay, so we are asked to prove that AB is equals to BC. Many methods, we have many methods, but we are going to prove it in one of them, which is we are going to draw a height from A to the line D2. It cuts it in H, and another height from B to the line D3. It cut it in J. Okay, so we want to prove BC equals to AH. We are going to take 2 triangles, prove them congruent, and AB and the CB will be the homologous elements in these 2 triangles. Okay, so these 2 triangles we are going to prove them congruent. As you can see, AB هي part من هذا الtriangle and BC also. So we want to prove them congruent. How do we prove congruent? We have 3 methods: side, 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 or side, angle, side, and the angle should be between the 2 sides, and angle, side, angle, also the side should be between the 2 angles. So let's see what do we have in these 2 triangles. We have first of all, we have said that these 3 lines are separated by equal distances. So this height AH is equal to BJ. So this is our first side. AH is equals to BJ, and we know that because for its height, so AHB it's equal to 90, and BJC it is equal to 90. Now how do we complete? So we have side and a 90-degree. Now either we can say that BH is equals to JC. Okay, بيطلع عندي side angle بالنص side، أو بدي يقول أنا عندي هاي الانجل side بيرجع هيدي الانجل. Okay, now this side CJ I do not have any given about it. CJ and BH I do not know، يعني أكيد هني equal, but I have no given about them, so I cannot mention them. What about this angle? CBJ and BAH. So they are corresponding angles. Can we say that they are corresponding angles? First, we need 2 parallel lines, which are BJ and AH. Why they are parallel? I do not have them, but I can prove them. Why AH is parallel to BJ? Because AH is perpendicular to D2 and BJ perpendicular to D3. D2 and D3 are parallel. معناتها AH and BJ they are parallel. Okay, so we have 2 parallel lines. So you can see the F shape. Okay, I will draw it. So the F shape هيك جايبة هيدا الرسمة. So these 2 angles they are corresponding angles. So بصير عندي أنا angle side angle. Okay, so here it is the angle, this side and this angle. وكمان بهي triangle angle side angle. So we conclude that the homologous elements will be one of the homologous elements will be that AB is equals to BC. Okay, now if you are thinking that they are right triangles and can I use hypotenuse and a side or hypotenuse and angle? Yes, it is right triangle. So these are right triangles, but we cannot use the hypotenuse and the angle or hypotenuse and a side because we are going to prove the hypotenuse. So we need to find that the hypotenuse in this triangle is equal to the hypotenuse in this triangle. يعني أنا بدي إياه ما في استعمله in order to prove it. Okay, so that's why we used the side angle, the angle side angle. Okay, and we conclude that the distance when we have a secant, okay, passing through or cutting three lines that have the same distance, how segments من هيدا السيكنت they are equal. مش بس ال perpendicular height هو equal، كمان ال segments من هيدا السيكنت they will be equal. So this is our conclusion. The segments formed by a secant, so these segments يلي هن formed by a secant drawn to parallel lines separated by the same distance. Okay, my mistake honey, the same distance. Okay, they are equal. Okay, so these segments are equal. Okay, in activity 2, we have the condition that in which D1 and D2, the distance between D1 and D2 and the distance between D2 and D3 is not equal. So we do not have the same distances as in part A or as in activity A. And let's see what happens. So we have two secants, the first one and the second one, of course, and we can obviously see that AB is not equal to DE, okay, and BC is not equals to EF. That is obvious. Type. We want to benefit from activity 1. So, but the distance between these two parallel lines is not equal. So I want to add lines. So I am adding lines to have equal distances. So here I added some lines in which now the distance between the parallel lines is equal. So the distance between D1 and this blue line is 1 box, and between this blue line and this D2 is 1 box, and so on. Okay, now I can benefit from activity 1, in which we know that if we have equal distances, these segments of the secant will be equal. Okay, so if I want to name them, let's say that the distance between A and the blue line is x, so this segment measures x, and also this segment, this red segment will measure x, and this red segment will measure x. So you can see that all of them will measure x according to activity 1. And also for the second secant, if this segment is y and we have equal distance between D1 and this blue line and this blue line and D2, then this segment, this red segment will be equal to this red segment. If this is y, then this is also y and this y, and so on. Now let's take a ratio AB over BC. So if we take a ratio AB over BC, okay, now AB, as we said, this is x and this is x, so AB is 2x over BC, it is 4x. Why? Because x plus x plus x plus x, it's 4x. Then if we cross x and x, okay, we can simplify x and x, and we can simplify here by 2, so divided by 2 and divided by 2, so our answer is 1 over 2. So this is our first equation. Now let's take the other secant. So regarding the next secant, okay, let's take the ratio DE over EF. DE over EF. Now, we know that because we have the same distance between these lines, so then this is y and this is y, as we said, then DE is equals to 2y and EF is equals to 4y. Also, we do the simplification and we divide by 2, so our answer is 1 over 2. This is our second equation. Then we can notice from 1 and 2 that AB is equals to DF. Okay, and here we are starting to know what is Thales theorem, and we can notice that parallel lines determine proportional distance between any for any two secants. So if we have parallel lines, and it is not necessary for these parallel lines to have equal distance, they determine proportional distance, okay, for any two secants. So this is the property is known as Thales theorem. Okay, I want to emphasize on something, that the ratio is equal and not AB is equals to DE. We have established that at first. So AB is not equals to DE and BC is not equals to EF, but the ratio AB over BC is equals to DE over EF. So, and this is Thales theorem. You should remember to respect the order. What do I mean by that? I mean by that in the previous slide we talked about the ratio of AB over BC. It is equal to DE over EF. So like the first section of the first secant over the second section will be equal to also start from the first section. So it will be equal to the first section over the second section. We cannot reverse that. So we cannot say AB over BC will be equal to and start from below equal to EF over DE. So if we start from above, we say AB equals to BC. We start from above, DE equals to EF. Or we can say start from the below the second section. So the second section, CB or BC, will be over AB equals to start from the second section in the second secant will be equal to EF over DE. But the important thing is that wherever you start here, you will start here. So respect the order. Okay. Now we have another ratio that we can form. Let's take it. So AB over AC. AB over AC. I will mark that. AB over AC. And let's see this ratio is equals to what? So AB, we agreed that this is x and this is x. So AB is equals to 2x, and BC it is x plus x plus x plus x. I'm sorry, AC. So all of that. So 2 plus 4 is equals to 6. So AB is equal to 2x and AC 6x. And then we can simplify x and x. And we can cross the common factor between or divide by 2. So AB over AC will be equal to 1 over 3. Now let's take in the same order the other side. So in the same order, like what? So we took the first section from the first secant, so we are going to take the first section from the second secant and all the sections. So here also we'll take all the section. So this is in this manner we are respecting the order. Okay, so let's see. DE over DF. DE over DF. DE is 2y and DF all of that. So if we count that y plus y plus y plus y, it is 6y. Then we can simplify y and divide by 2. So divide by 2 above and below, the answer will be 3. So from equation 1 and from equation 2, we can notice that these two ratios are equal. So if we respect the ratio, they are equal. So AB over AC and DE over DF. Next, applying Thales theorem in triangles, but first you should make sure that you have two parallel lines. So given PQ is parallel to BC, if we do not have this given, then we cannot apply Thales. So Thales applies whenever we have two parallel lines. So if PQ and BC are parallel, then according to Thales theorem, we have AP over AB. Let's say it on the figure. AP over AB over all that, respect the ratio on the other side, and we will say AQ, so the small section over the big section, equals to PQ over BQ. Now I like to think about it that we have small section, big section, small section, big section. This is small section over big section. Okay, and also you can say that, so I will mark that in another or I will erase that. Okay, I'm going to erase these and now we have, let's take the other ratio. You can see, or AP over PB, Okay, so we take small section, respect the order AQ, QC. Okay, so you can notice that in the first part of Thales theorem we have three fractions, but in the second only two. You can visualize it and see that in the first one we are taking a small section over big section, so a part of the side of the triangle over the whole side. So AB is the whole side, and then we are taking a part AQ over AC, which is the whole side, and then we are taking PQ over BC, which is the whole side of the triangle. That's why we are able to take PQ over BC here, but here we are taking AP over PB, so a section of the side over a section of the side over QC over AQ over QC. So we cannot take BC. BC is the whole side. This does not respect um, the order. That's why when we take small sections over small sections, only this is the order. These are two fractions. And also you can memorize or think about it like A, if it starts with AA and AA, so with the same letter, then we have three fractions. And if it doesn't, then we have two fractions. But I like to visualize it, to understand it. Why? Okay, and remember that we can always flip these fractions, so we can flip them. We can say instead of AP over AB, we can say AB over AP, but respect the order, so it's the same, but not AP over AB. So we just flip the fractions, so AB over AP. And on the other side, I can see that you may know that if you respect the order, if we start with AB, then on the other side we will also start with AC over AQ, which will be equals to AB over QP. So you can flip that, the denominator will be in the numerator. Yeah, so flip them all, مش انه وحده you flip it and the second will not. Respect the order, remember that. And also here we can flip them, so instead we say AP over PB, we can say PB over AP equals to QC over AQ. Now regarding the second figure, so the same applies. You can see that we have two parallel lines, so we can say that AP, okay, so on the same line, P, A and B, and Q, A and C, they are on the same line. So AP over AB will be equals to AQ over AC will be equals to PQ over CB. So one side of the small triangle over one side of the big triangle, respect the order. The side of the small triangle over the side of the big triangle, the side of the small triangle over the side of the big triangle. This is regarding to the first one. Or you can take small sections, but remember, when we take small sections, we cannot have a third fraction here, so it's only two fractions, so we can take a part of that. So AP over PB, okay, so AP over PB, يعني it is the side of this triangle and this triangle connected together, AP over PB كلها equals to AQ over QC كلها. But we cannot add PQ and CB, okay, they are not connected together. That's why we do not have a third fraction. And also we can flip them, so we can say in reverse, for example, PB over AP, not AP over PB, but you should reverse the second one. Next, applying Thales theorem in a trapezoid. So if we have a trapezoid, and also you should have as a given three parallel lines, AB and DC will be obviously equal because it's a trapezoid parallel, I mean, and EF should be parallel also to them. So according to Thales theorem, AE over ED will be equals to BF over FC, or we can take a whole part, so AE over AD كلها equals to BF over BC كلها. Okay, and EF it is not the mid segment. It's not necessarily that E is the midpoint. I can see that in this figure, it may look that E is the midpoint, but it's not necessarily for Thales theorem to be the midpoint. So this EF could be here. But the important thing is that they should be parallel. Okay? Finally, let's apply what we have learned. So, given EF is parallel to AB, great. So we can apply Thales theorem because we have parallel. Calculate the measure of FB. So EF is parallel to AB. We want to calculate the measure of this length FB. So you can take your time, pause the video, and try to solve it alone. So إن شاء الله تكونوا عرفتوا تحلوها. Okay, let's see. So I have EF parallel AB. طمنت راسي. I can apply Thales theorem. So according to Thales ما نشوف أي ratio ما نحط. Okay, so we can say that CE over EA. So بناخد part من السايد. So شخفة صغيرة. CE small segment over EA. respect the ratio باخد نفس الشي CF over FB. Okay, or I can say CE over CA كلها. So I take all of the side. So I can take 3 fractions when I take the side of the triangle كله. So CE over CA كلها equal CF over CB equal EF over AB. Okay, now I want to decide which one of these ratios أنا بدي. Okay, so I want the measure of FB. So I can say that I will use this يعني هاي FB. So I can say it's the easiest أكيد to use this ratio and أعوض ال EC بقيمتها وال EA وال CF and by cross يعني multiplication I can find FB. But also يعني if anyone likes we can use this ratio. So we can say that CA over CA equals CF over CB and write محل ال CB. اوكي هيدي الCB كلها حتكون 3 plus x. اوكي سو اكيد حتكون اطول حتكون complicated اكتر من الاولى بس انه you can do that. So you will take these two fractions. Okay, and محل الCB حنحط 3 plus x and make cross multiplication. Okay, but of course نحن بالعادة أكيد we take the simplest one with the simplest calculation and solve by it. So we will use this method. So taking the fraction containing FB because I want its measure, I'm going now to place each side in its value. So CE is 2 centimeter, EA is 2, and CF is 3 centimeters. And I want to calculate FB. So cross multiplication. So you multiply the means by each other and the extremes by each other. So 2 times FB equals to 3 times 2, and thus we have 2 times FB equals 2 times 3, and then FB equals 2 times 3, it equals to 6. 6 over 2 equals 3U. And what does that mean? So U, it is a unit because I do not know if it is a 3 centimeter, 3 meter, I do not know. So I say 3U, it means 3 units. In the next video, we are going to talk about converse of Thales theorem.